So good evening, and first of all, I'd like to appreciate the chance I got from the Levittown Public Library, and they invited me about maybe 3 or 4 months ago, and asked me whether I can make a seminar about the youth robotics competition, because they know I am enthusiastic in this area, and also I have been hosting the Make X competition for many years. So yeah, I'm really think it probably is a great chance for me, also for some of this audience, if you have not been experienced in the robotics competition before, or even you go to certain robotic competition, but you don't really sure whether you are really have interest in certain part of the robotics competition. And I like to give you some of this brief introduction, and hopefully you can enjoy that. And since this is really right before the Christmas, so I like to give you the warm appreciation and wish your whole family the very happy holiday first. Okay, my name is David Penn, and I have been working in IT industry for more than 20 years. And I am a former adjunct professor at SUNY, so that's State University of New York. And I have been hosting an organization called Youth Coding and Innovation Club since 2016. So I really have a lot of interesting about the teaching and also about the youth STEM activities. And I have 2 boys and 1 cat and 3 turtles in my home. So yeah, I really enjoy a lot of this activity with them. But one thing I most enjoy is really the hardware, especially the robotics. So let's start. Yeah, I definitely like to know what kind of robotics competition you have experienced, and whether you have certain interesting in certain part, because the robotics competition definitely becomes more and more popular. And I know there are a lot of kids join different competition over the years, but some of them probably only join one competition, but other like kids have experienced multiple different competitions. So that's totally fun. Let me try to give you some of this brief introduction. So hopefully you already know what's robotics. So I don't really start from the robotic, but I give you some of my personal experience of why we need to get involved into the robotics. I have 2 kids. 1 kid have been in the high school robotic team for 4 years. So he really loved that. And one thing I learned from the whole period of time is that the robotic really can help the kids to develop the problem solving skills. And also they are really concentrate on not only the science, but also a lot of like the math, like the mechanics. So they are really a real nice combination of multiple different angles, include software, hardware, also the mechanics, even 3D printer or 3D modeling. So you can learn a lot of stuff if you are really go through the whole process. Also, the robotics competition, not even competition, just program by itself, can build the self-confidence for kids. I still remember my younger son, he's really shy and he don't really like to speak out, but I feel really surprised. In his last year in robotic team, he reached me out and say, oh, whether I can host a small seminar for your student so we can introduce our team. So I say, yes, of course. I never really feel he can do that, because he really only have a small friend circle and don't really like to speak out. So that's a great moment when I see his change. And of course, if you are really high school student, you probably start to feel some sort of the urgency about, oh, whether I should find some of this future career. And so I can tell you the STEM, especially when you get involved in the robotics, some of this skill you learned will really help you for the long run. So robotics by itself is really a lot of fun. Okay, this is really something a lot of parents really care. Even the student may not really care at this moment, but I suggest you to take a peek. So if you check all of this slide, so this is really what's a major concentrate on: computing, engineering, physical science, life science, mathematics. So that's how many jobs available. That's how many graduate students. That's really the latest chart. So that's really the statistic based on the latest data from the, I believe it's from the United States Department of Labor. And you can see they have a lot of jobs available, but not really enough graduate students. So that means on the job market, these students are definitely much more welcome and they can find a lot of opportunity. I don't really say other major don't really have enough job. I just say compared to other major, the computing definitely have much more jobs than the number of graduates. So if you really have interest in and you are really like to step into this area, I would say the future for the employment or even for your, if you want to build your own company, you find a lot of opportunity over there. So this is also another one I really like to show to the parents. Of course, I know some of the audience here may not be the parents, but again, why we like to ask the kids get involved into robotics, not really go to other. Of course, we all send the kids to the sports camp, learning music instrument. That's all fun, and they all give them different kind of skill set which they can enjoy, and also they can shape their knowledge. But robotic by itself, I think it's really very important, which can give you almost all of this different angle. For example, if you want to give the motivation to the kids, this is not from me, actually, this is really from two professors that have been in this area for many years. I believe it's called Dr. Kami and Dr. Bush. Okay, so they are really studied the youth development for many years. So how to motivate the kids? It's really sometimes very challenging, especially for parents, even for school teacher. How to motivate the student to learn? It's very hard. So there are three basic criteria. One called the autonomy. So that really means how to get involved the safe initiation and safe regulation of one's own behavior. That sounds really fuzzy, but you just think about how to ask the student or kids to start do something by themselves. So that's something you can think it's autonomy. It's really things like the automatically doing or automatically motivated by themselves. Another one is the competence. Competence is really the ability to interact proficient or effectively with the environment. What that really means, that means they can really learning by themselves when they are really trying to go through the whole process. So that means you do not have to force them to say, oh, you must do this so you can go to the next step. Actually, they should able to go to learn from the whole environment. So that's very, very important. Also the relatedness. What that really refer to is the feeling of the closely and belonging to a social group. This part, when they explain this, it's hard to understand, but you just think about it's a group. So it's a group activity. It's pretty much like if you go to learning the music instrument, which one is more motivated to the kids? You teach them in your home. Of course, you have the private tutor, you spend a lot of money and time. It can be really good, but more motivated is when they join the school's group, right? So if they are joining the school's group and perform on the stage, they'll definitely feel much more motivated. So that's why robotics by itself can really give all of these three different criteria over there. So you do not have to force them to learn. They will learn through the whole program. You do not have to find the teammate for them, because they will have the teammate which they will love to get along with. Also, they can feel some sort of improvement over the time. So that's really a very self-motivated program, especially when the kids pass the first step. So that means that they already get involved and they start to learn something. Okay, so let's cut it short. And I know there are literally probably over 20 or 30 different kind of robotics competition for the youth only. And I will only focus on the top three. The top three is based on the statistic, not really I make up. So it's not really something I can really give you, but instead it's really the number what I get from the internet, right? So I only introduce the top three. The number one is called FIRST. This is a program's name, so it's not really something about certain company. Instead, it's an organization to organize all the competition. They have a brand name called FIRST. And then another one is called Vax, V-E-X. Vax is also a program's name, but it's also the company's name. And Make X is number three. If you compare this, how many countries that have the competition, you can see for FIRST, it's the biggest one. So they have over 110 different countries. They host by more than 79,000 teams. And they really use the cost of the company-made or called pre-made parts. And its competition is from the October in the first year to the next year's April, if you can make to the final. And Vax, it's really have more than 50 different countries. Every year they have more than 20,000 teams, but they are use the prescribed parts. That really means they are really use the company offered parts mostly. And the competition schedule is pretty much overlap with the FIRST. So it's from the October to the next year's April. And the MakeX, it's really hosted at over 60 different countries, and they have more than 12,000 teams every year. Similar to the Vax, they use the prescribed parts, so that means it's offered by the company. The competition schedule is slightly different. They are start from the March, but they are end by the December, so they are not really overlap with the FIRST and Vax a lot. Okay, so let's start from the number one. It's the FIRST robotics competition. And I guess a lot of parents probably heard this name before, but you may not really fully understand who they are and why they are start. To be honestly, my kids used to join the FRR team and compete for one season. I really enjoy that. They are really the number one in the youth robotics competition field, and they are started by a group of parents at 1993, I believe. So it's about almost 30 years of experience of history. They have been developed 4 different levels of competition. First Lego League Junior, JR means junior, and first Lego League, first tech challenge, first robotics competition. I will give you some brief description so you don't have to worry about if you don't really know this name. So the first is really very popular, and it has been globally reached a lot of audience. And this is just some of this number. For example, there have been in more than 100 countries, have more than 570,000 plus students participate. And they have more than 300,000 mentors, coach, judge, and volunteers. And they have more than 20 million plus hours, volunteer hours. And first, it's mostly based on the volunteer. So from the competition to the mentor, to the different team get involved, unless you are really in the school environment. Most times they are really based on the volunteers. And they also have some scholarship opportunity. And they host more than 3,600 events. So it's really the global footprint. It's really amazing program. This is really a very simple and short description about what's the first program. And if you see that they are divided into 4 different age groups. Some of this group are overlapping, but most of these are not. For example, from the age 6 to 10, you can join the FRR Junior. So it's really the team up to 6 members, and it's really the very much entry-level competition. I would say they do not really try to ask you to compete instead of have fun. So that's the most important part for the FRR Junior. And when you reach the age 9, you can start to join the FRR. That's probably one of the most popular one, and it can have a team up to 10, and they will build the Lego-based robot. And of course, they will also ask you to make the presentation of the how your robot was built up and what's a research topic. You try to find the solution for certain topic. Then the next level is very popular in the high school. It's called FTC. It's from the age 12 to 18. But most times I don't really see the middle school student join the FTC just because they do not have too much of this mental serve as a coach for this age group. So the team is up to 15 students. So they are really can help the whole team to build the very specific robot and compete head to head. The most advanced competition in the first program is called the A4c. It's for the age 14 to 18. So you can tell this is definitely only for high school students, and they can have a really big group up to 25 students. So this part is really some of this. I don't really say a lot. Some of this high school hosts this program, but it's really a very fun program. I have a friend, his son win about 3 years ago, win the A4c's world champion. So it's really a very nice experience. Okay, so let's start from the FRR Junior. Even this is really for the very first step, the entry level, grade K to 4. But it's really a very nice experience for any kids if they don't really have any previous experience before. So again, you can have up to 6 kids, and they are really trying to build a group to ask you to solve some of this guide research and imagination. What that really means is that they give you some topic and ask you to do some research, but they don't really say, okay, you just compete based on nothing. They give you a lot of help to prepare for that. So what they do is that they build a challenge-related model, and which use this is really the hardware we do, and they will ask you to create a show me post and practice. Then you need to make the presentation, and the competition is mostly based on the presentation. So it's not really a very challenge on the technical side. Mostly it's on how you do the research and also how you do the presentation. So it's a very nice experience, especially for the kids who are really never experienced for the STEM competition before at the young age. And of course, it was guided by the first core value. So they are really encourage you to cooperate and also have explore to different research type area. And then we'll ask you to discover the real world math and science based on the topic. So that's really about A4c Junior. This chart is really give you how they are growing. They'll start introduce that program at 2004, and at 2018, they already have more than 21,000 teams. So they have a lot of kids join this program. Since they are entry-level program, so they are really very easy to join. Not really say you have to have program skills or you must have some previous experience in robotics. You do not have to have any experience. So that's a very good entry-level competition. And they also have over 450 team, over 450 local explorers and world festival explorers. That really means they have a final competition. So it's really for a lot of kids, if they really enjoy that, spend a lot of time, they probably can reach to the final. Okay, so one level above the A4c Junior is called the A4c. A4c probably is a lot of parents know that. Some of this have the kids experience with this competition before. The team can be vary from like 2 or 3 kids all the way up to 10 kids. And the age is from 9 to 16. I don't know why here say 9 to 16. I don't think the 16 they can do it. But anyway, if they put over here, I just give you, oh, it's varied by the country. So it's pretty much from the grade 4 to 8. So I don't think 16 is okay. It's probably 14, I remember. Okay. And it's really used something like this. So this is a Lego Mindstorm. So the hardware is like this, and you will use this to make the coding and go through the whole competition. So every year they have different themes. So they give you different topic and then ask you to try to finish what's so-called mission. Most of this robotics competition called each challenge, small challenge called a mission. And the hardware they use is called the Lego Mindstorm. Of course, I will let you know they have one more set of hardware you can choose from. It's not really the Lego Mindstorm, but the Lego Mindstorm is probably most popular one. And they will try to ask you to apply the real world math and science concept. Also, you need to make the presentation. So that's very nice part of the competition. This is a chart about how the A4c was developed and grows over the years. So I think they start introduced A4c at 1998, and by the year 2018, so that's about 20 years late, they have more than 25,000 teams, and they have more than 281,000 students participate. Average team size is about 8 students. So they host a lot of competition, and they have the World Festival. So that's really, you can think this part is as a global final. So they have the global final. They reached over 103 countries. So it's really a very big competition global wide. Okay, we'll talk a lot about the competition, but for some of these parents or students, they never really go to the first before. So you're probably curious what this competition really looks like. So let me try to play the short video clip, and then you can see what kind of competition there really looks like and why you probably like to participate.
This is the replay competition field. There are 14 missions, which can be attempted in any order. You do not have to complete all the missions. Just try as many as you can in each 2.5-minute round. Only the score from your best round will be counted. Your robot must start from this launch area, and you should program it to return to this home area when it returns from the field. You can handle and modify your robot while it is in the home area. If your robot and all its equipment is small enough to fit in this small inspection area, you will score 25 points. Mission 1, Innovation Project. During this mission, you will use the white brick model that you have made that represents the solution to your innovation project. The robot moves your white brick model into the replay logo or to the gray area around the bench. Mission 2, Step Counter. The robot slides the step counter slow and steady. The further it moves, the more points that are scored. Mission 3, Slide. The robot slides the people off the slide and moves them to other areas, completely in home or on the heavy tire. Mission 4, Bench. The robot flattens the bench, removes the backrest, and gets cubes into the hopscotch spaces. Mission 5, Basketball. The robot gets a cube into the crate and raises the crate up the basketball post to the middle height, or to the top height. Mission 6, Pull-up bar. The robot passes completely under the bar in either direction, then later comes back and lifts itself off the mat at the end of the match. Mission 7, Robot Dance. If the robot is dancing on the dance floor at the end of the match, Mission 8, Boccia. If both share models have sent only one cube anywhere into the opposing field, then those cubes color match each other. If there are any color cubes in your frame or target. And if there is at least one yellow cube completely in your target. Mission 9, Tire Flip. The robot flips tires white side up, the heavy black tread tire and the light blue tread tire. If the heavy tire crosses the red flip line at any time, it scores 0. The robot moves the tires into the large target circle. Mission 10, Cell Phone. The robot flips the cell phone white side up. Mission 11, Treadmill. The robot spins the rollers to move the pointer clockwise. The further it moves, the more points scored. Gray, red, orange, yellow, light green, or dark green. Mission 12, Row Machine. The robot moves the free wheel out of the large circle and into its smaller target circle. Mission 13, Weight Machine. Before the match, set the weight machine to the color you want, blue, magenta, or yellow. During the match, the robot forces the large lever down until the little yellow stopper falls to score points. Blue, magenta, or yellow. Mission 14, Health Units. The robot collects health units from around the field, then moves them to target areas, touching the replay logo, touching the gray area around the bench, or looped over the pull-up bar post. Mission 15, Precision. If you interrupt your robot, you will lose a precision token. Precision tokens left in the field can result in extra points. Remember to read the robot game rules and check for any updates during the season. Good luck! Field.
Okay, so yeah, this video clip probably give you some of this basic idea about how the FRL challenge looks like, but I just give you some of this basic idea. The FRL game set and rule are really complicated. So on average, FRL have about 15 to 20 missions based on different seasons. So this is the challenge about 3 years ago, but every year they change it. So you do not really repeat the same challenge every year. Of course, you can use a Lego piece, thousands of different kind of Lego piece to build that robot on top of the Lego Mindstorm. So you can really have different kind of design. So that's really something a lot of team try to find out the solution for different mission. And again, you do not have to solve all of this mission. You can choose to solve certain mission and skip other mission. Of course, if you really want to compete and you really want to go to the award festival, so that's a final competition, you probably have to try very hard to solve as much as possible. So that's really the very basic introduction of the FRL. But for FRL, most of these kids, if you never really joined the team before, you probably don't really see that. But if you have ever joined the team, you probably see what's this. This is really the hardware they use for the build the robot, called the Lego EV3 or Mindstorm. And it has its own limitation, of course, because that's an entry-level competition. And they have only 8 ports. What's a port really means how many of this component you can connect to the main process. So that means they're pretty much like human. If you think this robot is like a human, right? So you can think this is really like the human brain. So they can only control up to 8 different components. For example, humans have limbs, right? So we have 2 arms and 2 legs, and we also have the eyes, and we also have a lot of components we can control by our brain. So do this. This is really the EV3 brain have 8 ports. So they can really be used for the motors and sensors. 4 of this can be used by the motors. The motor really used to make the move so that you can move forward, backward, make the turn. So they are really controlled on 2 sets of wear. And you also can control and connect the data from 4 different sensors. The sensor include the color sensor or the ultrasonic sensor, so they can measure the distance, something like that. So all of this Lego piece can be used. So you do not have to worry about whether you do not able to find the certain piece. Of course, you may not have this piece when you have not really start design yet. As long as you start the design, you probably will try to find the piece. So that's really part of the fun. And it was released back to 2013, and it cost about $465. Sometimes a little bit up and sometimes a little bit down. So this is really the hardware for the FRL. And I told you before, FRL also have another set of hardware released last year. So I just give you a chance to see how it looks like. It's called the Lego Spike. And it's really not designed to replace the EV3. If you compare to this is really more specific. So that's really more advanced. And this one is slightly easy to get into, but they have its own unique feature. So it only have 6 universal port. So the universal port means it can be used to plug in for the motor or plug in with any sensor. So it's not really necessary to say, oh, this port only for motor, that one is only used for sensor. So it has a little bit more limitations than EV3. If you compare here, it has 8 port, and this one only have 6 port. So when you only have 6 ports, so that means you have fewer choice when you try to build your own solution, right? And of course, it's slightly cheaper. It's only $340. Yeah, some of this team choose this one, and I will let you know another reason why they choose this one. And about the software, since we know the robotics, it's really the combination of the hardware, software, mechanics, and a lot of other design, right? So the software is also very important. For the FRL, the software, what they use is called the EV3G. And it's slightly outdated. I mean, the user interface is still very good, but they are not really as advanced as compared to other Scratch-based systems. So they have its own limitation. And the EV3 also supports Python. So if you really like to learn Python and start to build that, it can be done. So that's a plus side. And the latest development based on the Spike, based on this one, they have something which is pretty much the Scratch. So that's really something a little bit more easy for the development. So I would say this one is relatively cheap, have its own limitation, but the software side, they have one step ahead than the EV3G. And if you consider as the game, the whole schedule looks like this. So every August, like the August 1st, they will make the announcements. So they will release the FRL games rule and game set. So it's right in the middle of the summer, right? So the team have 3 to 4 months to prepare for their qualification. So that's prepare for the competition. And the later November to earlier December, it's really the regional and state championship game. So they really compete at the local level. And after that, in the January and early February, they will have the competition. I'm sorry. This is really the regional competition time. And the January and February, it's really the regional and state championship. So that means you will have to at least pass through the regional competition, then go to a state competition. And in the later April, they will have the World Festival. So that's pretty much a global competition. That's a final. So yeah, in case you are really build up a team really good and you can solve a lot of mission get a lot of points, and you probably can go through all of this competition. But most times, especially for the team who just build in the first year, and they probably join the regional competition and that's it. But don't be frustrated. You can always coming back to the next year. So it's really a teamwork. They build the team which can compete for multiple years, as long as you are in the same age group, so you don't really lose the qualification. Now let's talk a little bit about FTC, the First Tech Challenge. This is a very popular program in the high school, but you can see the age, it's really covered the middle school age. So in theory, you can join the competition even you are in the middle school, but most times the middle school do not have the team. So that's why they're still mostly for the high school student. The team is from like 5 to 10 different team members. They build the team together and they will build the robot. It's more specific to solve certain problem. So it's use a sports model. So that means it's head-to-head competition, and the team will design and program the robot based on the engineer principle. They will really use a reusable platform. So that means you were really able to use the same platform for many years. It was powered by the Android technology. So if you know your cell phone, some of you use the iPhone and others use the Android phone. So that's really the same platform as what we use for the cell phone. And the program language is mostly Java, but some of you can choose the Block. So that's really like the block-based language if you really don't feel comfortable about Java. And they really have a lot of competition from the regional level to the state level, all the way to the global final. So yeah, this is really a very popular program. And the chart here show you how it was growing over the years. The first year it was introduced is by 2005. And at 2018, it has over 6,800 teams global-wide. And they have over 68,000 plus students join the competition. The average team size is about 10 students. So they have a lot of competition at different level. They have the local competition, they have the state and qualification competition. They also have the world champion competition. It was really compete at 37 different countries. I mean, this is really for this 2018 to 2019 season. Since last year, most of this program has been held. And this year, I believe that has been resumed. And this is a short video about how the FTC looks like. Since some of these students probably have interesting about this more advanced program. So I like to play this for you guys.
Consists of up to 2 driver operators, a coach, a human player, and a robot. The robot must be built from materials specified in the game manual and fit within an 18-inch sizing tool, but may expand after the match begins. Each match is played with 4 randomly selected teams, 2 per alliance. Each alliance is allowed only 1 human player. Your opponents for one match may be your partners for another. The game is played on a 12-foot square playing field with a foam tile floor and 1-foot-high walls. 5 unique navigation images are located around the field perimeter. At one end are 2 tower goals, each containing 3 alliance-specific goals with return routes. Between the 2 tower goals are 3 red and 3 blue power shot targets. There are 2 red and 2 blue taped start lines, and 3 red and 3 blue target zone goals. and a white launch line divides the field. Outside of the field walls are the 2 Alliance stations and 2 human player stations. The primary game element is a ring, approximately 5 inches in diameter and 3/4 of an inch thick. A match is played with 20 rings. There are 2 red and 2 blue wobble goals. These can have rings scored onto them and can be moved for additional scoring. Before each match, teams place their robots on the field, touching the front wall and over one of their alliance's starting line. Each robot must be touching or be in possession of a wobble goal. A robot may possess or touch up to 3 rings. After the robots are in position, field personnel will randomize the starter stacks into one of 3 configurations. This determines which target zone goal is active in the autonomous period. 0, 1, or 4 rings correspond to target zone goals A, B, or C, respectively. Unused rings are stored in the human player stations to be deployed to the field at the start of the driver-controlled period. The players and field are ready. Each match begins with a 30-second autonomous period. During this period, there are a number of ways for teams to score using only pre-programmed instructions and sensor inputs. Delivering a wobble goal to the correct target zone earns the Alliance 15 points. A robot parked over the launch line earns 5 points. Each ring launched or placed into the low goal earns 3 points. A ring launched into the mid goal earns 6 points, and launching into the high goal earns 12 points. Robots earn 15 points for each power shot target knocked down. Robots must be completely within the launch zone to launch rings into the mid goal, high goal, or power shot targets. Following the autonomous period is the 2-minute driver-controlled period. During the driver-controlled period, human players are expected to return rings to the playing field, as well as reset power shot targets. Each ring launched or placed into the low goal earns 2 points. A ring launched into the mid goal earns 4 points. However, rings launched into the opposing alliance's goal earn points for their alliance. A ring launched into the high goal earns 6 points. The last 30 seconds of the driver-controlled period is the end game. During this time, robots may continue scoring rings, but there are also ways to earn bonus points. Each knocked down power shot target earns 15 points. Returning a wobble goal to the start line earns 5 points. Each ring fully supported by the wobble goal earns 5 points. If a robot lifts a wobble goal over the front wall into the drop zone, its alliance earns 20 points. There are many ways to score in Ultimate Goal, but there are also rules that, if not followed, will deduct points from your alliance. For example, a robot may not.
Okay, we have limited time for the presentation, so I don't really play back the whole video, but you get the basic idea how it was done. Again, this is really only for 1 year of competition. It's not really say every year they will be the same. Something you can repeat. That's not. Okay, so let's move to the A4c. A4c is really the most advanced competition for the first program. So it can have a really big team, and they will build a really big robot up to 120 pounds. So it's really a very big one. And if you think about that, it's pretty much like the human size, not really as tall as human, but it's really a very big robot. I don't really introduce too much about this because the A4c is not really as popular as another 2 program, but they are really very specific for the high school student. If you have team in the high school, I strongly encourage you to join that team. And they are growing over the years. Of course, if you compare the number, not really as popular as FTC and FLL, for the good reason, because it's cost a lot of money to build that robot, right? Okay, and now let's move on to the Vax, very popular one, and they are really divided into 3 different levels. The entry level called the Vax IQ. It's really for the elementary school student and middle school student, so they can compete. It's called the Vax IQ Challenge. The elementary school student can be grade 6 or lower, but the middle school student is usually 7 or 8. The basic team requirement is 2+. Typically, you have 2 to 6 team members to build a team for the Vax IQ. And I like to play a short video for that, so you can really see what the Vax competition looks like.
One game, Vex IQ Challenge, rise above.
First, 2 teams will collaborate in 60-second teamwork challenge matches, working together to maximize their score. Both teams will receive the same points.
Each of these teams will consist of 2 drivers and 1 robot. One driver will operate the robot for the first half of the match, and the other driver will operate it for the second half.
Second, each team will have the opportunity to compete in the driving skills challenge. In these matches, teams have 60 seconds of driver-controlled time to score as many points as possible.
Third, each team will also have the opportunity to play programming skills challenge matches in which they have 60 seconds of autonomous robot operation to score points, no drivers allowed.
Scores from the driving and programming skills challenges will be combined to determine a robot skills challenge champion.
Vex IQ Challenge Rise Above is played on the new, wider field, measuring 6 feet by 8 feet.
Robots and game objects start on the field in predetermined positions, and there are 9 goals located around the field.
Be sure to double check the robot size rules this year, as they may not be the same as previous Vex IQ Challenge games.
The scoring objects are risers, with a height of approximately 8.75 inches and a width of approximately 7 inches. There are a total of 27 risers on the field.
The object of the game is to score as many points as possible with your alliance partner by scoring risers in goals and completing rows.
Each riser scored inside of a goal is worth 1 point. Each riser stacked on top is worth 1 additional point.
If teams score 3 risers of the same color in a row, they will have a completed row and will earn an additional 3 points.
If teams can stack 3 risers in the same goal, and that goal is part of a completed row, they will have a completed stack and will earn an additional 30 points.
Teams will have to experiment with different scoring configurations to figure out the most efficient way to score points.
For official game rules and robot requirements for Vex IQ Challenge.
Okay, so this is a very basic introduction of, again, this is only for 1 year's competition, so don't really assume they will repeat the same. They will not. So most mission, and this is really the hardware used for the Vax IQ. So this brand, or you can think this is a main process, have totally of 12 ports. So if you compare to FLL, it's only 8 ports, so this have 4 more ports. It can be used for either motor or sensors. In the competition, you can only use up to 6 motors, so you do not able to use too much motor just because they want to make that to be with certain limitation. And all the robot with that competition will require the wheels to be allowed the robot move freely. So they have some platform you can build like this. So they are really introduced this back to 2012, and you can see each set is about $379. So this is how the Vex IQ's robot looks like. And that's the hardware part. About the software part, they use something called the Vax code block. It's pretty much, it's a Scratch-based block coding language. If you ever learn Scratch, you probably feel very familiar with this interface. Actually, this is supported by a lot of different platforms, like the Windows, Mac OS, Android, iPad, Chromebooks. You can also use the Vax code text for some of this more advanced student. It was really written in the C++, but most likely the Vax IQ, I mean, for their age group, probably you will not really write into the C++, just because it's a little bit more complicated. Now let's talking about schedule. So the Vax competition, it's really start from the beginning of the season is called the October. So that's a regional competition. Of course, the typically release that in the earlier than October. So by the October or earlier November, you will have the regional competition. And after that, in the later February and early March, you can join the regional state championship if you are qualified. Of course, that's really based on your ranking. And the world championship is really in the later April. So they are pretty much overlap with the FRL, which means it's very, very hard for one team to join both competitions. So you probably have to make the decision whether you join the FRL or you join the Vax. So either one is really a good program, but unfortunately, you can only join one of that. And now let's move on to the Vax V5. Previously, it's named as Vax EDR. It's really for the middle school and high school students. And so each team will have the chance to build some robot like this. It's much more advanced than Vax IQ, but you will see why it was built for this. I'll play a short video for that. So since we don't have too much time, I probably will not play the full length video.
To the world's greatest 2 minutes in robotics, the 2021-2022 game, Vex Robotics competition, Tipping Point. Tipping Point is played on a 12-foot by 12-foot field by 2 alliances, one red and one blue, made up of 2 teams each. The object of the game is to get more points than the other alliance by scoring rings, moving mobile goals to alliance zones, and by elevating on platforms at the end of the match. The VRC Tipping Point field consists of 72 rings and 7 mobile goals. Each alliance has 2 alliance mobile goals, with the remaining 3 goals being neutral. Each alliance also has a platform located in their home zone. Rings are 4.125 inches in diameter. Each robot starts the match with up to 3 rings as a preload. Rings scored in the base of a mobile goal are worth 1 point each. Rings that are scored on an alliance mobile goal or on the lower branch of a neutral mobile goal are worth 3 points each. Rings that are scored on the high branch of a neutral mobile goal are worth 10 points each. Rings that are scored on an alliance mobile goal will count
most other
plus the points
student and parents may not receive that.
Mobile goal. As the match draws to a close, robots will start heading back towards their alliance platforms. Each robot that ends the match elevated on a balanced alliance platform is worth 30 points for that alliance. And any mobile goals that are elevated on a balanced platform are worth 40 points. Each match begins with a 15-second autonomous period, where robots can score rings or race to the center of the field to snatch an early advantage in possessing mobile goals. The alliance that scores more points in the autonomous period is awarded with a 20-point bonus added to the final score at the end of the match. Each alliance also has the opportunity to earn an additional win point in the autonomous period by scoring at least 1 ring on each of their alliance's mobile goals and clearing their autonomous win point line. The 1-minute, 45-second driver control period begins once the autonomous bonus winner has been determined. At the end of the driver control period, after all scoring objects and robots have come to rest, the match will be scored to determine the winning alliance. Remember, VRC games are not scored until the driver control period has ended. VRC Tipping Point can also be played in skills challenges, where one team competes against the clock, remote skills and live remote tournaments, where teams compete from their own homes, The collegiate level Vex Iq competition, where teams design 2 robots using advanced materials, and the Vax Ai competition, a completely autonomous challenge using industry-level machine.
Okay, so yeah, this is really about how the Vax V5 looks like. Also, Vax have another program introduced recently called the Vax AI. It's the most advanced competition. It's pretty much for the high school student, also the university student. So it's a pilot program, not really have been very popular yet, but it will gain the popularity over the year. So I don't really give you much introduction about this part, but you can think about that this one will come with some of this more advanced technology. Okay, so now let's move forward after we introduce the number 1 first and number 2 Vax. It's a time for us to introduce another not very well-known program in the United States, but it's gained a lot of popularity in a lot of other countries, include South American, include Asia Pacific, and it's called the MakeX Robotics Competition. So this is a map which give you how they looks like in different region. So you can see in Asia, Europe, Oceania, so that's Australia, and African and South American, North American. So they have more than 60 different countries, have more than 20,000 teams, have more than 100,000 contestants, and they have a lot of audience over the different countries. This competition was really designed with 5 different tiers. So they have the MakeX Spark. I will give you a little bit more introduction about what's a MakeX Spark, but you can think about from the beginning to the more advanced level is from the Spark to Starter to Challenge to Premier. So for each program, they have different audience. The MakeX Spark, to be honestly, it's not really a robotics competition. Instead, it's more like a hardware and software creative competition. So it's more like a project-based competition. You can think it's like a science fair project, but more about the technology side instead of science side. So you have chance to build a team up to 4 students with 1 or 2 mentors. You can use different kind of STEM kits to build a project which can compete based on the theme. So each year they have different theme. That's pretty much referred to different topic. So you can compete on different topic. For example, this year they have the future home as a topic. So that's 2021 season. You can build the project based on how you can make the enhancement of certain feature for your home. So that's, you can imagine what can be done for your future home. So that's really based on different topic. And then the next level of the competition is called the MakeX Starter. A MakeX Starter, it's really the entry level robotic competition. And they have been used for the MakeX Starter kit. So this is really the kit. I forgot to put the price over here. It's about $250, something like that. And the age group is from 6 to 16, but it was breakdown into 2 different age. So if you are really in the elementary school and the middle school age, probably you can join the lower tier. And then if you are in the middle school to the high school age, you can join the higher tier based on different age group. They are naturally compete mixed together. So the bigger kids will compete with bigger kids. Each team is 1 to 2 students with 1 to 2 mentor. So the student size of per team is relatively small. So that means each student have to be more handy, and their I would say it's more hardcore. So you have to be really like to play with a robot, but you can learn a lot. So that means compared to the team 5 to 6 students, each one of you students have to do its own job. So they are really have much more burden, but at the same time, you develop the skill set much, much faster. Then the next level, okay, before we move to the next level, I'd like to play the video so you can see what the competition really looks like. Of course, this is for the next season, so it's only the animation.
Make X Robotics Competition. Make X Starter, Zero Carbon. Make X Starter is a multitasking competition program. The competition should be finished by red and blue teams as an alliance. The size of the map in the Zero Carbon arena is 2,317 millimeters by 2,317 millimeters, and it is divided into an automatic mission area and manual mission area. The size of the robot shall conform to technical requirements. The maximum size of the robot shall be 280 millimeters by 280 millimeters by 300 millimeters in length, width, and height. There are 4 starting areas in the arena. Robots start their match from the respective starting areas. The competition consists of 5 independent missions and 3 alliance missions. The whole match lasts 240 seconds, which consists of an automatic mission stage and a manual mission stage. The alliance teams will determine the duration of each stage. There's an additional 30 seconds preparation between the 2 stages. When the automatic stage begins, robots can score through the following actions. 1. Within your own mission area, move the small yellow cubes completely out of the resources area. Each yellow cube is worth 30 points. 2. Within your own mission area, remove the small red or blue cube from the manufacturing area. Each small red or blue cube is worth 30 points. 3. Within your own mission area, drop the yellow ball from the energy storage power station into the yellow area. Each yellow ball is worth 50 points. 4. Within your own mission area, remove the red balls or blue balls out of the breeding frame and keep the green balls on the breeding frame. Each red or blue ball is worth 30 points, and each green ball is worth 30 points. 5. Within your own mission area, remove the red balls or blue balls from the warehouse. Each red ball or blue ball is worth 30 points. 6. There are 3 recycling areas in the central of the automatic mission area. The alliance teams need to move the yellow cubes into the recycling areas. Each area with any number of yellow cubes is worth 30 points. 30 seconds preparation stage begins after the automatic stage. After the preparation stage, the manual stage begins. Robots can score through the following actions. 1. Collect the red balls and red cubes in the tropical forest farm, and collect the blue balls and blue cubes in the frigid forest farm. Each red ball or blue ball is worth 10 points. Each red cube or blue cube is worth 30 points. 2. Move the team markers placed in the manual loading area into the marking area. Each team marker is worth 30 points. At the end of the competition, robots on both sides shall stop immediately. The team with the higher points will get a higher ranking point in the competition. Welcome to the 2022 Make X Starter.
Okay, so that's pretty much the introduction of next season. So that's animation of the robot of the Make X Starter competition, and the Make X competition also. So the challenge have built a much bigger robot. You can compare that to the FTC. So it's a pretty complex, big robot, and the team can be up to 8 students. So you have a much big team. Of course, you will have to really break down that team most likely into the software, hardware, also the mechanic, probably some other like the structure. And it's really require a lot of very specific skills, but it's not necessary to say every student have to have the same skill set. You can have the nice combination as a whole group. The age group is from 11 to 18. Of course, it's mostly for the high school student, but the middle school student can start to join the competition. It has nothing wrong about that part. And if you see this side, it's really a much bigger side of the competition. Since this is just a picture, so you probably don't really able to see and have the feeling of how big it is. You can think each one of this half, it's like a queen size bed, that size. So two of this, like the two queen size bed put together. Let me play the video of how the next season, so that's 2022 season of the challenge competition looks like.
Welcome to the 2022 MakeX Robotics Competition. MakeX Challenge Energy Innovator. MakeX Challenge is a confrontational competition program. The competition is held between the red and the blue alliances. Each alliance consists of 2 teams and they must cooperate to complete certain missions. The size of the map in the Energy Innovator arena is 2,985 millimeters by 4,185 millimeters, and it is divided into red and blue sides. Robots of both sides can only operate within their own side of the arena. The size of the robot shall conform to technical requirements. The maximum size of the robot shall be 500 millimeters by 500 millimeters by 700 millimeters in length, width, and height. There are 4 starting areas in the arena. Robots start the match from their respective starting areas. The whole match lasts for 280 seconds, which consists of an automatic stage, a manual stage, a modification stage, and a final stage. During the match, the robot can score through the following actions. Mission 1, within your own alliance side, connect the yellow balls from the energy utilization station and shoot down the pins on the opponent's side. Mission 2, in the central area of the arena, sort the cubes from the new energy data collection center to your own side. Mission 3, place or stack the cubes in the new energy data computing center on your own side. Mission 4, insert the cube into the new energy data storage center on your own side. Mission 5, transport the pins to the energy recycling area on your own side. Mission 6, hang your team's flag on the flagpole in the flag hanging area on your own side. Mission 7, collect the alphabet cubes with letters M, A, K, E, and X to your own alliance side. The 30 seconds automatic stage begins. The robot can complete missions 1, 2, 3, 4, and 7. The 100 seconds manual stage begins after the automatic stage. The robot can complete missions 1, 2, 3, 4, 5, and 7. The 60 seconds modification stage begins after the manual stage. Contestants can move the robots in the starting area out of the arena for modification. After the modification, the length and width of the robots shall conform to the technical requirements, while the height has no limit. At the end of the modification stage, the 90 seconds final stage begins. The robots can perform all missions. At the end of the competition, robots on both sides shall stop immediately. The scores of Energy Innovator will be calculated according to the final state of the scoring props. And the scores of the props are as follows. In the renewable energy area, each valid pin is worth 25 points. In the energy recycling area, each valid pin is worth 20 points. In the data storage center, each valid cube is worth 30 points. In the data computing center, each valid cube is worth 15 points. Except for the data storage center and the data computing center, each valid cube on your own side is worth 5 points. On your own side, select the alphabet cubes with letters M, A, K, E, and X to complete the Make X challenge and get an extra 150 points. In the flag hanging area, each valid flag is worth 50 points. The alliance with higher points wins.
Okay, so as what you can see, that's really about more advanced competition. And now let's go to the last one, and it's called Make X Premier. This one is pretty much like the first A4c. So it's for the students have more advanced skill set, and they will build the robot one step above what the challenge team can build. And the field is also slightly bigger than the challenge field. So you can see this is pretty much similar, but much bigger than that. Each team will from 2 to 8 students, have 1 to 2 mentors. You can build that. And it's really available for the high school student only, and also for the university student. So let's going back to the Sparker a little bit. Since we are really here to introduce the robotics competition, but I would like to emphasize what's really the Make X Spark. The Make X Spark, it's really a program which have been attract a lot of kids, especially when they are during the pandemic, the COVID-19, right? So they do not really have chance to really work with the team member. Instead, they can really build something by themselves. So this is really a very good program, which if you have interesting about software, hardware, but you are not really have too much chance, or you are not really have the friend circle big enough to build a team to compete, you can build a team by yourself. This is really basically a competition for the project based. So you can really build a very specific project. Of course, this is not a robotic competition, but I strongly suggest somebody, I mean, if you really have interest in to build the project-based, join the project-based competition, give it a try. And it has an online format, so you do not really have to go into compete face-to-face. You can build that, shoot a video, and then upload the video. They were based on the rules and policy and give you the score. The higher score will get you invited to join the global competition. Again, the starter and innovator, the challenge, they all have the different levels. So they have the regional competition, they have the countrywide competition, they also have the global competition. And I would like to give the time frame. So the time frame for the Make X competition is slightly different. Probably go to the very first page so you can see it. They are really start from each March. So it's pretty much the end of the first and Vax competition, the Make X start. But even at March, they don't really start the competition yet. So they are really release the program so you can start to build the team and start to train the training your own robot. And during the summertime, you probably can have more formal training and you can build the team, solve the mission. Most of the competition are really in the September, October, sometimes in the November. And the global competition and the high level competition is in the December. So they are pretty much covered about half year of time frame, and they are not really overlap with these two competitions. So I give you a quick summary. If you want to join first or Vax, you probably can only join one of this because the time it's really overlap. You cannot really say, I build a team, join both competition for the first and Vax. It's almost impossible unless you are really manage the time very good and the competition have no time confliction. Most times it's very hard. Make X, it's not really during the same time frame, so if you are really joining the team in the first of Vax, you probably still can join the team for the Make X if you really want to. And also some of this criteria you like to consider is how much money you want to spend. I would say during this multiple years competition, the Vax is most expensive if you go to the high level, but the first half the most expensive if you go to the highest level. So A4c is very, very expensive. Make X have good price for the entry level, but for the middle tier, they are pretty much the same as Vax and also FTC first. And if you really have interesting to build the team, the first thought is go to the school and ask the school whether they have existing team. But unfortunately, I know most of this school do not have the entry-level team. So that means the FLL Junior or the Vax IQ or the Make X Starter, they do not have team. If you want to join the team, most likely they have the FTC or they have the Vax V5. So this kind of high school team that they will build. The good part for the high school team is that you have the teammates you know pretty well, so you can really use that time, like the off-school time, and to study with them. And you also have time to really work with the mentor. Most times it's the high school teacher. So that's a good part. But of course, they also have its own drawback. That means you choose that high school robotic team means you cannot join other high school off-school program. So that's really always a trade-off. Personally, I really encourage you to at least give it a try. Any one of these three competitions is very popular. Also, they are very specific. They give you a lot of chance to build your skill set from the software to hardware to the mechanics, even to 3D modeling, or a lot of other skill set, even presentation, leadership, because they build a whole team. So really lead the team captain to really lead the whole team. And over the years, I have experience with different team and different group of kids. So I know how specifically they are really looking for learning and also the skill build up from different robotic competition. Of course, we have a very short time tonight, so I don't really have too much chance to interact with you guys since I have to present a lot of content to you guys. But just in case you have interesting to contact me, you can send email to info@ycic.club, and I would like to answer your question. Just in case you have interesting to build your own team or even just join certain program. Yeah, I'm really like to discuss with the parents and the student about different part of the robotic competition. Personally, I host the Make X competition for the New York metro area. So I am the hoster, but I don't really say that's the best choice. I never think that's the only choice. You have a lot of choice from the first Vax and Make X. It depends on your time and your goal. So again, I really appreciate your time to join this presentation. And I know it's really the end of the year. So I hope you enjoy the holiday season. And I really appreciate and I would like to see you join the robotics competition team or you build up the robotics competition team in the coming year. So